Hi, I'm an old guy and I do maths, and today we're going to differentiate this expression here, 5x times e to the 3x. So the first thing to do is to recognize that this will be an application of the product rule, and I've written out the product rule here, possibly in a way in which you might not find familiar, but if you just accept that what we're dealing with here is f, and what we're dealing with here is g, and you think of these as possibly the more familiar form, if you haven't seen this before, of u and v. And so what happens is that the differential of this entire expression is equal to the differential of f, or u, times g plus f, or u, times the differential of g, or v. So it works exactly the same way as the rule that you might have seen in some textbooks. You do see this in some textbooks, and I like it because it just feels to me to be faster and neater. Okay, so we're going to use this rule, and we're going to apply another little rule, which is this one here. So if we have an expression a times some sort of function, and we have to differentiate that, we can rewrite this in this form. Now, just let me explain that in really, I hope, straightforward terms. So if I have something like 2x to the power of 3, what I'm saying is that this is a and this is f here. And so if I differentiate this, what I get is I get 6x squared. Now, I could just as easily do the following. I could write this as this. I could differentiate this, and what I will get is I will get 3x squared, and what I'm going to wind up with is 6x squared. So that's what I'm going to do with the expression 5x here. I'm going to take out the 5, and I'm just going to set that aside as a multiplier, which we will come back to later. So, in that case, if we take a out of the equation, the function of x actually becomes x, and the derivative of that is 1. Now, the derivative of the function g is as follows. It's the derivative of it's the derivative of this times the whole expression. So it is 3 times e to the 3x. Okay, so let's start filling this in and see what we get. And this turns out to be not a particularly daunting proposition. So we take the derivative of x, which is 1, so that winds up there, times g, which is e to the 3x, so that's 1 times e to the 3x, plus the derivative of e to the 3x, which is this expression here, and I'll just circle this so that it's really clear as to what that is. So it's that thing there, and we multiply that by x. So we wind up with 1 times e to the 3x plus e to the 3x plus 3, which is the derivative, times 3, which is the derivative here. If I said plus any time, please ignore that. I meant times x. So we tidy all this up, and what we get is we get e to the 3x plus 3xe, so we can We can write this in a number of ways. We can write it as 3e3x times x, or 3x e to the 3x. I prefer this. And don't forget the 5. The 5 has been hovering outside of here the whole time. And that takes us just back up to this little trick here. Basically, all we had to do was derive the pronumeral, in this case x. But it could have been a more complicated. It could have been a more complicated thing. It could have been a quadratic of some sort, and we would still take out the common factor and derive what was left. Anyway, the net result of all of this is that the derivative of 5x e to the 3x is equal to 5 into e to the 3x plus 3x e to the 3x. That's our answer, and that is how you get it. Okay, well, thank you very much for watching. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.